Just a minute. Uh, Everyone, myself, Sir Assistant Professor PIT. Today we have with us Miss Vaisali Patel. She is a senior developer, senior manager at Pragmatic Solution. She is having more than 5 years of experience in software development and machine learning using Python. So today she is going to discuss about the one of the most trending topic about machine learning and how we can use the machine learning with the Python. So, Vaishal ma'am, welcome to Parul University. Uh, we are glad
Thank you.
that you are going to share your knowledge of to our students for machine learning and Python. So, over to you, ma'am.
Good afternoon, everyone. Our topic is brain-computer interface. Brain-computer interface is brain-computer interface is a BCI. BCI is the most emerging technology now onwards is used. It's a field of a neurotechnology that translates brain activity via signal into commands to the computer or electric devices. Okay, so BCI is very useful to in every applications, every areas to make that artificial intelligence. Okay, so the system is controlled by electroencephalography signals. It is a type of non-invasive. Non-invasive means you can't cut or else you are doing. You are simply electrically getting that EEG signals. So BCI applications used in a very uh, have a very emerging areas like medicals, entertainment and gaming, neuromarketing, educations, neuro neurological, security, authentic, and in like you can say that virtual reality environment as you can see in our topic is based on this spelling machine P300 spellers. So EEG signal, how we can use that EEG signals to spell a particular keyword from the targeted data. Okay, so it's a main use we are learning about that. So now, and for BCI EEG device, we are using the headset device. Headset device are have multiple nodes like you can see here. It's a different number of nodes. There is 32 nodes or 64, 152 different nodes are available to get the signal of our mind, to use that signal for the further applications. So this is the main flow, you can say it a flow. So it's BCI signals. These BCI signals used to signal acquisition. What's a signal acquisition? Signal acquisition is a task to acquire a recording brain signal and remove the noise signal data. This data is a pass-through processing task for the further feature extraction and a reduction according to our application. There are a main two types of a brain acquisition method.
Hello,
Invasive method.
Vaishali madam.
Yes.
Excuse me, Vaishali madam. Your screen is not visible.
What?
It is blank.
Now
No, still it is blank.
screen is not visible. Now it is visible.
Yes, madam. It is visible.
Okay. 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 So there are mainly two type of signal acquisition. Okay. First is the invasive and second is the non-invasive method. Invasive technique is the electrodes are neurosurgical implant either inside or user's brain on a scalp. So get using that electrode we are getting the signals. And a non-invasive method is brain activity is measured using external sensor. We are using these sensors to get the signals. Now that signal used for the further processing for a reduction, noise reduction, and for further. Now using a classification. Classification component are used to translate product feature into a device's command. Different machine learning classification algorithm is used for the classification. In our main areas, we brain computer main research paper you can refer and you can notify that LDA, CNN, SVM that are mainly machine learning algorithms used for the BCI signals, EEG signals classification. That classified signal used for the further application like P300 spellers or any other else. And that application you are getting some feedback and you modify accordingly for further future. Okay. Now what's a P300 signals? Event related potentials, ERP. ERPs are the smallest voltage generally generated in a brain structure in a response to specified event and stimuli. P30 signals is a 300 P300 waves positive peak, positive or negative peaks. It's a target up to 300 mg UV, and that signal you are using for the our ERP related potentials, and that signals used for the further classification. Here is a P300 and non P30 signal. Blue lines are a P30, it's a caller targeted, and others are a non-targeted signals. Why P300 signals we are using for the our spelling system? Because EEG signals have a different millisecond microseconds have a different level of signals arise. From that we are using only P300 because that signal we are using that for the further getting the keyword. You can find the character from that like at this different peak, up down these signals. From that down to up, that may you get the particular A character, other signal you are getting the B character. So from that signal you are identify the characters, and using this character you can find the verse, which verse we are using. So it's mainly P300 speller. Speller is a system which allow user to communicate by a focus of attention. In our project, there are specific database used. Here, P300 speller have use user means you can say the client or a patient that have to focus on the screen. This screen have A to Z character. So have to focus on a particular character. So this speller continuously moving from horizontal and rectangle wise. So if I am focusing on M, then this speller give the result of M. From that we can easily identify that client is focusing on M character. It's a 6 by 6 matrix. You can speller has a 6 by 6 matrix character classification symbols, and row and column highlighted targeted as a character. Mainly two softwares are available: BCI 2000 and OpenVibe software used to acquire real-time EEG signals. And as I mentioned, these are the number of nodes. See, this P2, P3, PZ. From top to bottom, the central vertical line has a Z character like OZ, PZ, CZ, FZ. So these are a different node. From that we are acquiring EEG signals. Okay, why we are thinking about to getting in these particular eras? Because BCI helps to communicate the disabled persons who are totally locked in, who cannot even open close his eyes or not even speak. So using a brain signal you can easily communicate that this is particular comes in his mind. Okay, in a contribution in a medical field in a range of prevention and neural rehabilitation. In a serious injury, if there is a serious injury, then also we can uh, prevent that particular. Okay, to create a mutual understanding between a user and a surrounding system, like a smart house. You smart houses also have that switch on the lights. So they understood the command, the understood the it's basically a sound wave. But if it's a BCI system used, then EEG signal means if you are thinking, then also that occur in a real time. Brain computer interface need to overcome the technical difficulty as well challenges poses by a user acceptance to deal with such a newly discovered technology. If there is a newly discovered technology is available, then if you are facing something challenges and that is not recoverable from that, then BCI is helpful. Okay, these are a different research papers you can refer for the further. Okay, mainly we are using that this database is BCI competition 2 database 3. This database we are using for the P300 signal. Okay, and this database, how this database created. So um, for that one lab have ALS. ALS means amyotrophic lateral scenario patients. These 20 patients are available there. They have three different conditions like a copy spelling, pre-spelling, and free use. Copy spelling in the sense you have a spelling and you have to focus on that particular spelling. Pre-spelling means you randomly choose, and free use means you can think whatever you want to think. Means you don't have a target, and that speller identify what you are thinking. On basis of that EEG signals, we are uh, collecting the data, and that data transferred to the matrix format in a MATLAB. So that BCI competition 3 database to mainly use, and different algorithms are used for SVM stepwise linear description database, CNN, multilinear prescriptions, ReLU. Okay, different databases are used for that. What are the challenges in BCM? There are many. Every technology have a different challenges available in the this world. Okay, so there are information transfer rate, such as a system is a too far or a too low. There are may possibility that if your system have a hardware issue, or your electric node devices that are implanted on your scalp may not have a higher accuracy, that may because you are not getting exactly signals, so you're not getting the exactly result what you want. The error rate during the input is a very high due to high variable brain signals. May possible that the signals rate, the frequency may have too much high, too much low. Okay, autonomy is really given since sensors using we are using a sensor, so may sensor have a difficulties, may not. So then cognitive load, which is under the distraction the brain generated different more noisy. This noisy signal is you can say disadvantage to not achieve the particular goal. Okay, so main objective, what's the main objective of that? So using the VEG signal, using the devices, you are getting the P300 signal. The particular EEG signal, from EEG signal detect the particular P30 signal, and from that signal you are going to characterize that particular character. So what's the P30 signal? To detect the presence of P300 in EEG and reduce the calibration time. To classify P3, improve their information transfer rate and remove noise and reduce the error rate. So combination of different P3 signal to use the target character. Okay, now a different machine learning technique which are using. So first, for as we discussed that first we use a signal acquisition, for that feature extraction, particular feature extraction, which features will be used and which features are not will be used, how to remove the uh, how to reduce the size of data, how to get the excel optimized data from the raw materials. Okay, so first of all we are doing the sampling. There are a low pass, high pass. So from sampling the particular signal, low pass and high pass, we are filtering the subsample and we are getting the exact range of the signal. Low pass, you can say that a millisecond can have a too much high millisecond, matlab up and down. These signals have a different frequency. You all may see the graph of the EEG signals. Okay, so from that you can low and high pass, you can get the particular range of this. Now segment, define a marker with the segmentation interval. So you can define the particular interval is event or a cut of the data around the time interval. So it is used to get the perfect data. Okay, mean. Now calculate the mean of the selected channel. From sampling and segment, we are getting the particular range of the signals. From that selected signal, we are calculating a mean. The time interval are chosen by a sign R square. The interval, we are using the R square values for the further. And now concate appends the average value to generate a feature vector of each trial channel. We have a feature vector for each channel and each trial. Now appending matlab mean concatenating everything, and now can perform a classification algorithm on a generated feature vector to train a model. Now here different algorithms are used, as I said that LDA, SVM and CNN. LDA, linear description, it's a machine learning algorithm. LDA is used LDA, also known as a research LDA, is used to hyperplane to separate the training feature vector representing the different classes. See, as you can see in this picture, there are a number of red and number of the lin, uh, linear discrimination analysis is a maximize the distance between group. So here see, PC algorithm maximize the variation of the set. So here we are using this angle. In LDA, you are using a different projection. For this is a projection which help to maximize the distance between the red and a blue, means high and a low signals. Okay, the location and orientation of the hyperplane is determined from the training data. Now SVM, support vector machine. What's a support machine? There are two different classes available, and one optimal hyperplane line is available. Okay, there are different like A and B. Okay, from hyperplane we are using the hyperplane, from that they maximize the difference between class 1 and a class 2 different classes distance, and that distance is maximized which hyperplane used to divide two classes. Okay, SVM combine a different individual SVM subclassify result to produce the final result. So hyperplane used for the separated two classes, and after separation one class's data used for the result, and which reduce the interface of a EEG noise and impact on a subclassifier. So class 1 you can getting the unnoisy matlab after removing noises you are getting the most filtered data, so which is useful. Now convolution neural network, there are one level convolution, two level convolution, multi level convolution neural networks available. CNN is mainly used in most of the areas, and see using a CNN most probable you may get the accurate result. It's a automatic learning, its advantage is a automatic learning feature represented from the raw data. So now you have a matrix of 64 cross 78. Here is the image. Okay, see L0, it's a 64 cross 78. L0 as the image. So now you are, after that image will convolute and subsample. Now this 64 cross 78 is divided into L1 M0, means first column first column every row, matlab L1 M0 up to L1 M and S1. So now and again this L1 M0 is divided into L2 M0. Now it's divided into different divided from half of the rows, half rows part in a one first one and another first is another one. So subsample particular and convolution, there are equations used for the convolutions uh, to get the reduce the noise and to get the particular. So these are a division, and from that divisions we are getting the final combined in a one column as a fully connected, and we are getting the result at f and n. So cnr are able to host a full potential of a recognized bci signals. So here the output layer, this layer has only one map, two neurons which represent with a two class of the problem. One is a P300 speller, another is a non P30. This layer is fully connected. Okay. Now again we can repeat the particular diagram again. So here L0, it's a 0 less than I less than an electron up to I and J divided into. So it's a n up to n electron. Okay. There are hidden layers in between. Hidden layers are used they are only one layer, two layer or multiple layer. Here we are using the three hidden layers. Okay. First layer, first hidden layer is a composed NS map. Means each map has a anti size different, like here as a 78. Okay. Now L2 has a second layer. This second layer is composed to 5 and 3 map. Each map has a 6 neuron as we discussed, as he represent here. And the third layer is composed of a one map of 100 neurons. This map is fully connected to the different maps of L2. Now the four output layer is has only one map of two neurons which represent two classes. Okay. We can measure a performance to examine that performance of this particular classification of a different algorithm, that which one is a good or which one. Mainly use the different performance measurement like f1 score, precision, recall. Here we are using a f1 score. F1 score is calculated using the precision and recall. What's a precision? Precision is a true positive divided by true positive plus false positive. What's a true positive? True positive means the data. Data have a truth and also it's a positive. True false positive means may it's a not a positive, it's a positive but its a result is a false. Same as the recall is a use for true positive divided by true positive plus false negative. And F1 score is multiplication and division by its a addition. Okay. Now this is the flow. See, this is a EEG signals. This EEG signals is used and use apply some classification algorithm. From that algorithm you get the this kind of diagram, or you get the data have p300 and non p300 signal. So this signals classification will further use for the character recognition, that these are the characters which are used, these are the characters which may not be used, and further. So here are the flow, you can purpose flow diagram which I use, that feature extraction, it's a classification, it's a characterization. So characterization, we are understood up to classification. Now it's a characterization. What the characterization? So characterization is characterizing the particular character. We have a signals. These signals may have a target, may not have a target. If you are using that focus on a particular character, then have a target that must be the answer. But if it's a pre-use, then we don't know that which character will be the answer as a character. But character recognition is use, we have a different level of uh, we have, I don't have right now, but I have a signals. Like see, it's up to first signal low band passing may have a result as a character. Another is a signal up to this may have a B character. Third signal may have a D character. Okay, so that signal range and that signals area, from that we characterize a particular character, that this signal is using for this character. And this characterization will use for the predicting particular character, and we can finally measure the performance, that what the result we are getting and what the answer we are getting. So for that we are using the, as we said, as I said that BCI computation 3 database 2 is using. So this database have different attributes. Attributes like flashing, stimulus code, stimulus type, target character. Flashing. Flashing is row and column intensified. If it is a row intensified, then say 1. If column intensified, then if not intensified, then 0. Okay, so intensified means it's a focus, and that focus character, that character in which row, which column. So if row or column intensify, accordingly have a value 1 for a yes and 2 for a no. Other attribute is the stimulus code. Stimulus code, which is a row or a column, is being intensified. Row or column is being intensified. 0 for no row or no column. If 1 to 6 column is so intensified code, so that we have a 6 cross 6 matrix. If first column is intensified, then in stimulus code have a 1 number. If 6 number column is intensified, then have a number 6. If um, second row is intensified, then have a 8 number, because 7 for a first, 8 for a second, 9 for a, so 7 to 12 is used for a row, 1 to 6 used for a column, and if no column or row is intensified, then say 0. This is a stimulus code. Attribute is the attribute main of the database. Now stimulus type is containing desired character. It's means this is if the signal have a character, specific character, is a desired character is included or not. If containing the desired character, then it's a 1. If not, then it's 0. Now some of them have a target character, some of not. If have a target character, then correct character label. So target character have 0 to 9, A to Z, and underscore. These are the characters mainly used in a 6 by 6 matrix. So target character give the answer if they have a means if you are focusing on a M and have a target and from the attribute other than flashing stimulus code and stimulus type, we are classifying and characterizing the character that it is and not M, then that we can finally match the target character with the uh, characterizing character. Okay, as I say, database P300 speller with the ALS patient neuroelectric imaging at the BCI laboratory. IRCCS Foundation Sound Rome, Italy. In an Italy laboratory, there are this database created using the 20 ALS patients. The database represents a complete record of P300 evoked patient and they are using the BCI 2000 software for that. In that study, a total of 8 volunteers, all native, have BCI training. 3 are women, and uh, for different EEG signal, we have knowledge of the patient, like about its age, about its gender, because every human have a different signals and signals are affecting on their current uh, age, status, and etc etc. Okay, so they mention the different other things as well, like about their patients. Scalp EEG signal were recorded from 8 channels. So, as I said, there are 64, 152. Right now, there is the possible that 152 electrode devices also available. Uh, so, 8 channel from FZ, CZ, PZ, OZ, P3, P4, PO7, PO8 using a active electrodes. So that are active electrodes used, and using that electrodes we are they are getting these signals and their signals use collecting the signal and create the database. So uh, also tried I also tried that this is a EEG devices. Say you can say this is a EEG device, it's a real time images, and I'm using the CZ, OZ and PZ device, CZ, OZ and FZ electrode. From this electrode, I am getting this kind of signals. Okay, these signals but for further uh, you can say process, we have must have a devices to get these signals in our system and further modulate, because particular software are using for that. Okay, this is a 32 channel. As you say, see here has a A1, F7, PG1, FZ, CZ, C4, P4. So different nodes are available, and it is a 32 node headset devices. Okay, right now also available that devices are different wearable, so it is easy to capture other than this. Okay. Now plot the R square. Sin R square value for the subject A, top rows and subject B for, so it is subject A and subject B. Subject A and subject B is are different users. Okay. So we have a different nodes. You can see it there. PZC, PZC, CFZ. Okay, and which node have a different oscillator. Okay, the channel are sorted from the frontal and occipital, and within each row from left to right, from left to right, and from frontal and the occipital, we are get collecting the data. The blob shows the time interval. Here are blue and pink blobs. Okay, that blobs shows the time interval for each channel and which discriminant based against the other class. See, these are the different other subjects have a different oscillators available here. So it is a classification of P30 and non-P30 signal. So this is a absurd signal. So each and every node we getting the different signals. So in absurd you are getting this, and from CZ you are getting this kind of, and PZ have a different. So this is a class wise average time course of a two subject for three selected nodes. So class-wise average time goes for a subject 1, subject B for a 3 selected channel. The average are calculated on the whole time training. T is equal to 0 millisecond is the onset of a simulation. So it's a zero simulation. Zero simulation is this original origin of these signals, and from that we are getting these signals. And here you can say purple purple line is a targeted and a blue line is a non-targeted. The targeted means a P30 signal who is picked up to the 3 millisecond. Okay, now it's a spatial topography. It's another kind of diagram of the average voltage distribution of a different time interval used for the classification. This also using for the classification of a subject and it is getting from the top row shows the non-target trials and the bottom row the target. Okay, so here this plus symbol showing that this is the node, particular area of node, which node. So and this is 150 to 250, it's a time interval and this is a voltage interval. Okay, so from 0 to 3 this is a upside and this is a downside. So we are getting the signals and which signal is focused on a which area for subject A and for subject B. We are getting this kind of diagram. So now I have the particular constructed label, and we have a existing label. So some of these labels we are calculating from is same, but as you can say WQXPZCOMRKOW, but here is KO9. So these are different. So we are not achieve the 100% accuracy, but we reach up to the 91% for two subjects, subject A and subject B, two different client patient. Okay, and this is a true label already available in our database, and this is a constructed label. We this construction is constructed label from the different algorithm and so now conclude that BCI is the fastest growing research field. So work on a 32 electrode base and feature extraction used for the reducing processing time. An improvement. Propose you can SVM LDM algorithm to achieve a 90 and 91% accuracy. Then construct the character using a P300 signal, compare a label with a true label to evaluate. Uh, I published two research papers. First one is uh, brain computer interface application and P300 speller in IEEE Explorer. In the conference ICICIT at 2019. And another one is a comparative study of the classification technique for P3. It's published in another conference, not in a Springer. And we use different reference papers for further. Hello? Any question? Any question?
Hello.
Yes.
Yes, completed. Hello. Thank you so much, madam, for sharing your knowledge with our students. In behalf of our university, I am thanking you again for sharing your knowledge and your time for us. Thank you so much, madam.
Thank you.
Jiten sir. Hello. Jiten sir.